Okay, good morning, everyone. Now, having gone through the adaptive immune response in brief, we will proceed to the actual chapter on autoimmunity. The first part of the chapter is immune tolerance. So far we saw how the adaptive immune response recognizes an antigen, gets activated, and finally eliminates the pathogen. Today, we are going to learn how it discriminates between what is a pathogen and what is not a pathogen. So that discrimination is referred to as immune tolerance. So learning objectives will be that at the end of this session, you should be able to define what is tolerance and explain how it is important, medically. You should be able to enlist which are the various mechanisms and classify them. So which are the various mechanisms of tolerance in the two limbs of adaptive immune response. So we are all very aware that our immune response does not act against our own antigens. So it identifies and learns to coexist with our own cells. Whereas no sooner is it presented with a foreign antigen, it reacts. This phenomena that it recognizes and attacks a foreign antigen and does not attack the self antigen is simply referred to as self-tolerance. So we'll learn the actual definition in a while. Now, if this first part, okay, recognizing and reacting against a foreign antigen is defective, what will it lead to? So that is what we call as immunodeficiency, inability to mount an immune response against a foreign antigen. If the second part, that is, it normally does not attack a self antigen, if that is defective, what will it lead to? That is precisely what autoimmunity is. Okay. So autoimmunity is strictly defined as the presence of antibodies or T lymphocytes that react with self antigens. So basically, it refers to the presence of autoreactive lymphocytes. Okay, autoreactive means self-reactive. If it is B lymphocytes, then we call them as antibodies because that is what their mediators are. For T lymphocytes, we simply call them T cells because it's cell-mediated. So, but I mean, the definition does not indicate that it is actually causing an injury. Okay, it is merely stating that these antibodies are present. Whereas in autoimmune disease is that which results from tissue injury caused by such autoimmune reaction against its own tissue. So autoimmunity is merely the presence of autoreactive lymphocytes, which we'll learn in the next class that even normal people may exhibit some antibodies against themselves. Okay, or even some antibodies may get released or may get formed if you are, if you have suffered an injury. But that was a result of injury rather than it being the reason for the injury. But autoimmune disease is when the injury results from the immune reaction itself. So that is the difference between the two. So these are some of the autoimmune diseases, a few of which we will cover in the next class. I hope you have heard of pernicious anemia. Maybe you have heard of myasthenia gravis. Of course, type 1 diabetes mellitus is something which all of you know. So if there are autoreactive lymphocytes against one's own pancreatic beta cells, it can result in destruction of those beta cells. Systemic disorders, which of course are very significant, but you might not have come across them. Systemic lupus erythematosus is one common example. Rheumatoid arthritis is another. So we'll see them. The question for this lecture, the cardinal question is, does the body naturally produce self-reactive immune cells? Because if the body was only manufacturing lymphocytes against a foreign antigen, there was no question of tolerance. The question arises if this is possible. Now, is it possible to naturally produce self-reactive immunocytes? Just take a moment to answer that question. What is this? Can you identify this diagram? So this diagram is what I briefly covered in the T cell receptor chapter. Of course, this particular diagram is not from the T cell receptor, it is from the B cell receptor. So this is simply a heavy chain of the immunoglobulin. But before this gene gets formed, there are several steps involved. Okay, so this gene of the heavy chain is made up of a blue segment, a green segment, a yellow segment, a red segment. Let's call them variable, diversity, joining, and constant. The constant mu indicates that this is an IgM heavy chain. Okay, so now go a few steps behind and you see what is this. So this is the germline DNA. What do I mean by germline? That it is present in each and every cell of the body. So like I said, each and every cell of the body has antigen receptor genes, but they are present in scattered form. बिखरे पड़े हैं अलग अलग सेगमेंट में. बट जब वो जुड़ते हैं एक दूसरे के साथ तब वो एक फंक्शनल जीन बनाते हैं. Okay, so they need to come together to make this functional gene. And where does this happen? This happens with the help of two very important proteins, two very important gene products known as recombination activating gene 1, RAG1, recombination activating gene 2, RAG2. So RAG1 and RAG2, they become active only in the B cells, in the developing B cells and the developing T cells. And there, because of the action of RAG1 and RAG2, there are cuts made in so that one variable fragment, one diversity fragment, one joining fragment, one constant fragment will come together to give rise to this. So you can see there are n number of segments, V1 to Vn, m number of segments for D, D1 to Dm, J1 to JQ, and so on. For C, of course, there are, you have only two. In the surface immunoglobulin can only be IgM and IgD. So there are C mu and C delta. It is only after the class switching that you get IgG, A, and E. So initially it is IgM and IgD. So constant दो fragments आपके पास हैं. So these are the various, let's say, how many combinations are possible? ये N है, ये M है, तो N into M into Q. अगर ये 100 है, ये 50 है, ये 20 है, तो इतने तरीके से ये recombine हो सकता है. 100 into 50 into 20 like that. So you have taken one of these VH, one of these DK, one of these JP, and you have made a random assortment of genes. And that is how you get your final B cell receptor or final T cell receptor. T cell receptor में भी यही होता है. So my question was, does the body naturally produce self-reactive immunocytes? What's your answer now? So immune cells, now this is very important to remember, okay, that marriages are made in heaven. What does that mean? The immune cells are genetically pre-programmed to express receptors against a unique antigen. So just remember that the pre-programming, just a moment, I'll pause for a while. Pause recording. Okay, I'm back, sorry. Do you remember from the last class I said that marriages are made in heaven? So immune cells are genetically pre-programmed to express receptors against a unique antigen. And that happens how? Through random recombination in the central lymphoid organs, that is in the thymus and bone marrow, random gene recombination using RAG1 and RAG2 happens, and that produces a random B cell receptor, a random T cell receptor, which is unique, and that is uniquely expressed on that particular cell. So what is the natural implication of this? That it will produce a very random thing. Why is it important? I mean, why is random recombination taking place? See, because we are totally unaware of what kind of viruses, what kind of bacteria, what kind of foreign threat we are going to face. So the body tries to maximize the repertoire. What is repertoire? The range. The body tries to maximize the range of weapons that we have. So तरह के अस्त्र जमा करता है body. So like, for example, right now we are dealing with the SARS coronavirus 2. Okay, so once this virus enters a person's body, what will the body try to do? It will mount an innate immune response against it. 80% of the individuals will be successful in warding off the threat using the innate system itself. For the remaining 20%, it might evade the immune system and it might enter the cells. Okay, it might enter into the cells. So now the body needs cytotoxic T lymphocytes to come and kill those infected cells. But अभी क्या problem है कि हमारे पास we don't have memory cells against it. We only have naive cells. Okay, most of the population, all of the population. So that is the present situation, that none of us have memory cells against it. We are not immune to it. We are all new to it. But that doesn't mean that we don't have naive cells. So we do have naive cells, and that is how people are recovering, and their serum is being used to harvest their antibodies. So the process of random recombination naturally produces receptors against an infinite range of antigens. That is what I meant. Now, this infinite means foreign, but it also means self. So refers to, okay. So my point is that when the random recombinations are taking place, the good thing about it is that it will produce antibodies or T cell receptor against everything. Sabke against bana dega. The bad point is that it will also produce antibodies or T cell receptor against your own antigens. Okay. So tolerance refers to unresponsiveness to an antigen induced by exposure of lymphocytes to that antigen. Okay, just change it slightly to mean that unresponsiveness to a specific antigen, which is induced by exposure of lymphocytes to that antigen. So there are two parts to this definition. One is that it is unresponsiveness that is specific for a given antigen. So it is an active antigen dependent process. Contrast it with immunodeficiency. Immunodeficiency mein kya hota hai? Like someone suffering from HIV, someone suffering from cancer, or someone to whom you have given steroids to suppress the immune system. So they will be deficient, they will mount a very low immune response against several organisms. Okay, maybe like HIV patient ko candidiasis bhi ho sakta hai, he can have viral infections, he can have widespread fungal infections, he can have parasitic infections. So that immunodeficiency is very general. Okay, it is not a very specific immune deficiency. This one is very specific. So it refers to unresponsiveness to one antigen induced by exposure of that antigen to the lymphocyte. So one is that it is specific for a given antigen. Second is that it is induced by prior exposure to that antigen. Okay. So ऐसा नहीं है कि वो एक भी बार expose नहीं हुआ है. कहीं ना कहीं the B cell or the T cell were exposed to that antigen and it was trained to say कि नहीं ये अपने ही घर के members हैं, like marriages are made in heaven, but you cannot marry someone from your own family. So this is from your own family. You should avoid, अच्छी बात नहीं है. तो ये बताया जा रहा है, he is being trained, but that happens after prior exposure. So tolerance, like I said, is unresponsiveness to an antigen. Self-tolerance is unresponsiveness to one's own antigens. Okay, self-explanatory. It is the breach in this self-tolerance that leads to autoimmunity. So clinical significance, like I said, it prevents the body from mounting an immune attack on its own tissues. तो अपने फैमिली फ्रैट्रिसाइड नहीं करना है या सब शादी नहीं करना है खुद के साथ. Prevents inflammatory reaction to many innocuous airborne and food antigens found in the mucosal surfaces. Innocuous matlab harmless. Okay, innocuous means harmless. So I'm basically referring to the various commensals, the microbes which normally reside in our nose, in our gut. Okay, so nowadays we say that I'm a microbiome. I'm not one individual. I represent millions of organisms living within myself. So Saket is just one, and then there are million other cells like bacteria, viruses, and all. So these innocuous, harmless food antigens, airborne antigens, it is the body learns to tolerate them as well. So but they are not self-tolerance. Okay, they are not self. So they are foreign antigens, but the body can be trained to become tolerant to them. So they are all such antigens are known as tolerogens. We also call them as tolerogens. Now, how can it be exploited therapeutically? Therapeutic मतलब medically आप इसको use कैसे कर सकते? See, the purpose of learning about immune system, it is very important it is very interesting to learn about immunology, because we live in a surrounding where we are covered by bacteria, viruses. हम कंटिन्यूसली कांटेक्ट में आते रहते हैं दूसरे ऑर्गेनिजम्स के, तो हमारा इम्यून सिस्टम ही है जो हमें सिखाता है कि कौन हार्मफुल है कौन नहीं है. So that particular thing is very important. And then if we want, and once we have learned this, we can tweak. तो हमको चाहिए कि इम्यून सिस्टम का पावर बढ़ा दो. और कैसे बढ़ाना है पावर? लेट्स से रेगुलेटर बढ़ाना है, 5 पे कर दो. बाय रिड्यूसिंग द टॉलरेंस, टॉलरेंस को कम कर दोगे तो आपका इम्यूनिटी का पावर बढ़ जाएगा. सो लेट्स से यू हैव अ डिजीज लाइक कैंसर, आई हैव नॉट मेंशन्ड हियर. सो कैंसर में the immune system sometimes fails to mount an attack. Okay, the cancer cell masquerades as self antigen, खुद को सेल्फ दिखा के बच जाता है. तो अब इस केस में आपको इम्यून सिस्टम को बढ़ाना है, तो तब आप टॉलरेंस को कम करोगे. ऑपोजिट सिनेरियो इज दिस, जब आप ट्रांसप्लांट करते हो, ओके, रीनल ट्रांसप्लांट किया, यू डोंट वांट द बॉडी टू रिजेक्ट दैट ग्राफ्ट, तो आप क्या करोगे, इम्यून सिस्टम को कम कर दोगे, 2 पे कर दो, ओके, 1 पे कर दो इम्यून सिस्टम को. कैसे करोगे? बाय इंक्रीजिंग द टॉलरेंस. यू मेक द बॉडी, you train the body to live with this, to coexist with this particular graft. Similarly, in case of autoimmune and allergic diseases, जो हम पढ़ेंगे अगले क्लास में, तो autoimmune disease अगर है, you want the body to decrease the immunity, कम करना है, तो आप tolerance बढ़ाओगे उसका. So in that case, you train the body to increase the tolerance. So that is the therapeutic role. I told you, जब आपको immunity का power बढ़ाना है, 5 पे करना है, तो tolerance को कम करोगे. इम्यूनिटी का पावर कम करना है, 1 पे करना है, तो आप टॉलरेंस बढ़ाओगे. So mechanisms, which are the various, first part was learning about definition and its medical importance. That part is covered. The next part, a bit lengthy, please stay focused. So this part deals with how this tolerance, how this training, telling that okay, this is our own family and don't marry them, how this is done. So it is divided on the basis of where it happens. Central, peripheral, self-explanatory again. Central means central lymphoid organs, thymus, bone marrow. Peripheral means peripheral lymphoid organs. Peripheral lymphoid organs which are spleen, blood में spleen हो गया, lymph node, lymphatics में lymph node हो गया. So spleen, lymph nodes, and then a couple of other lymphatic tissues. One is the mucosa associated lymphoid tissue, MALT, which includes your pharyngeal tonsils, pairs, patches, and your cutaneous lymphoid tissue. So basically what I'm trying to say is that central tolerance मतलब जहाँ पे उसका random gene recombination हो रहा है, where the receptors are getting formed. So at that stage itself you tell them, basically in your childhood only you explain कि this is our family, you don't marry here. Whereas this is where now they have become adults, now they are no more children, and they are still meeting, they have not learned their lessons. So अब ये जा रहे हैं कैफेटेरिया में, कहाँ मिलते हैं जाते हो, गर्लफ्रेंड से, बॉयफ्रेंड से, you will meet at a certain place, you will meet at a movie theater, in a mall, at a cafeteria, in a disco, in a club, whatever. So those are the places where they'll meet. So these are the places: lymph nodes, spleen, MALT, cutaneous lymphoid tissue, where the B cells and T cells meet their partners, prospective antigens, right? So since they have not learned their lesson as children, now you need to train them. तो अभी तुमको हिंदू युवा वाहिनी और जो भी सेना वेना है वो बन के जाना है, वैलेंटाइन डे पे तोड़ फोड़ करना है, तो यू वांट टू डिसरप्ट देयर pleasure, so you go there into the spleen, into the lymph node, and there you induce the tolerance. Okay, so this is for immature, like I said, children. Immature self-reactive T and B cell clones are killed in the central organs itself, whereas यहाँ पे है कि अब mature but self-reactive. I hope all of you are getting it, that as children you try to train, but not all of the children will listen to you. Similarly, central tolerance is not perfect, so some cells will invariably escape into the circulation. So now these are a threat. So these potentially self-reactive T and B cells that escape to the peripheral tissues are eliminated using peripheral tolerance. Some of the mechanisms of central tolerance include clonal deletion, receptor editing, and some of the mechanisms of peripheral tolerance include again clonal deletion, Anergy, and suppression by regulatory cells. So formation I have mentioned here, but यहाँ पे वो काम नहीं करते. Regulatory cells का काम यहाँ पे ही होता है actually in the periphery. Okay, so we'll see one by one. So immune tolerance is divided into central and peripheral. Central, in the thymus, for immature T cell, there is clonal deletion. In the bone marrow, for B cell, there is both clonal deletion and receptor editing. Peripheral, like I said, there is energy. This is nothing but clonal deletion. Deletion को apoptosis से ही होता है, तो वही है. And then there is suppression by regulatory cells. So how we'll see one by one. The same diagram again. So for T cells, central tolerance is by deletion, or peripheral tolerance is by deletion and anergy. For B cells, central tolerance is by deletion and receptor editing, and peripheral is by anergy. This diagram is repetitive, so just for your revision, yeah, we'll proceed. So central tolerance. So like I told you, it happens for children, बच्चों के stage. So immature B and T cells में क्या होता है? Now we are talking of T cells. So T cell receptors are randomly generated by recombination in the thymus. Like I told you, the advantage is that diversity, protection against an unpredictable infinite number of pathogens. But the disadvantage is autoreactivity, that invariably some T cells will recognize your own self antigens. So this problem is solved how? That the final T cell repertoire is a French word, means range. So the final T cell range will be shaped by interaction of these immature T cells with self-peptide MHC complexes. So the thymus के अंदर जो एंटीजन प्रेजेंटिंग सेल्स हैं, उनका ये काम है कि वो अपने भाई बंधुओं को लेके आएंगे, या लड़कियों को, या जिसको भी, एंड इसको इमेच्योर बच्चे को ही दिखाएंगे कि देखो ये तुम्हारे फैमिली की है. Okay, so self-peptide MHC complexes will be displayed by the thymic antigen presenting cells, and that will shape your T cell repertoire. So क्या होता है? तो there ये दो जगह होता है, कॉर्टेक्स में भी होता है, मेडुला में भी होता है, एंड इसके दो आउटकम्स होते हैं. सो 2/2 हो गया. So it is happening at two places, and everywhere at both the stages it will have two outcomes. Either the cell will survive or the cell will die. Outcome मतलब एकदम जमीन आसमान का फर्क है. So the fate of the T cell, this T cell जो auto reactive है या नहीं है, fate will depend upon whether it is able to recognize these things or not. So either it will survive or it will die. So in the cortex, what happens is the positive. So this we had already covered in cell-mediated immunity wala chapter. Positive selection and negative selection. So in the cortex, cells are selected on the basis of whether they are able to recognize MHC or not. Okay, this is known as MHC restriction. So basically, just imagine कि 10⁻10 cells पड़े हैं दुनिया भर के अलग-अलग तरीके के जीन रिकॉम्बिनेशन वाले, अलग-अलग T cell receptor वाले cells हैं. अब कुछ फिल्टर लगाना है, तो आपने पहला फिल्टर क्या लगाया कि भाई MHC आप रिकॉग्नाइज करते हो कि नहीं, whether you are able to recognize MHC. The first filter is simply MHC. So all cells which will recognize MHC will survive, rest will receive, and rest will die. Okay, simple. अब MHC recognizing cells मेडुला में पहुंच जाते हैं. कहां पे? मेडुला में. From the cortex to medulla. यहाँ पे होता है negative selection. So here अभी तक वो सेल्फ पेप्टाइड वाला बात आया नहीं था, अभी तक MHC पे ही बात हुई. So second filter is here. Second filter tells them कि these are my antigens. Okay, this is my insulin, this is my growth hormone, this is my whatever, my immunoglobulin, जो immunoglobulin को भी अटैक नहीं करना है तो वो भी दिखाओगे. So all those cells are shown. This is my liver cell, this is my gastric cell, this is my whatever. So so negative selection is what happens in the medulla, and that eliminates your autoreactive T cell. So this is what is responsible for self-tolerance. The first part is only MHC restriction. So that is not actually part of today's chapter. But this self-tolerance is what we are mainly going to cover. So positive selection. So this is your T cell precursor. Okay, जो bone marrow से thymus आया, random recombination of genes हुआ, immature thymocyte बन गया. इसके अंदर सब कुछ था. तो इसके अंदर mainly एक unique T cell receptor आया. Okay, genetically pre-programmed to recognize a unique antigen. And then इसमें सारे CD थे. CD8 भी है, CD4 भी है. सो अब कॉर्टेक्स में क्या हुआ, पहला फिल्टर लगाया पॉजिटिव सिलेक्शन कि भाई एमएचसी रिकॉग्नाइज करते होगी, सो दिस इज अ थाइमिक एंटीजन प्रेजेंटिंग सेल, dendritic cell or whatever macrophage, and it has both class 1 class 2, you know, antigen presenting cells have both. So now this will come and stick. तो अब डिपेंडिंग अपॉन वेदर, अब ये वाला जैसे क्लास 1 को रिकॉग्नाइज कर रहा है, ओके क्लास 1 को, तो ये देख रहे हो तुम रेड, तो CD8 के साथ ये बाइंड कर रहा है, CD8 और CD4 के साथ नहीं कर रहा है, CD8 ये ज्यादा स्ट्रांगली क्लास 1 को रिकॉग्नाइज कर रहा है, तो इसका फेट हो गया कि ये CD8 बनेगा, इसका CD4 चला जाएगा, तो इट बिकम्स अ CD8 सेल, whereas ये वाला, so depending upon which MHC, see these are recognizing the MHCs, these are not recognizing the MHCs, so ये इनको finish कर दो यहाँ पे, 90% of the cells die at this stage itself, only 10% आगे आते हैं नेक्स्ट स्टेज के लिए। तो पहला ऑडिशन जो होता है, ऑडिशन में ये इतने पास हो जाते हैं, पास होने पे भी जो MHC 1 को रिकॉग्नाइज करेगा उसका, सी इनिशियली दे आर डबल पॉजिटिव, CD8 CD4 पॉजिटिव, डबल पॉजिटिव से यहाँ पे सिंगल पॉजिटिव हो जाता है, based on if they are recognizing MHC1 they will be called CD8, if they are recognizing MHC2 इसमें खाली blue CD4 रह गया, तो ये CD4 will survive, CD8 will go, so ये आ गए, अब तुम्हारे पास सारे MHC recognizing clones आ गए हैं, and now negative selection in the medulla happens, that is they will be shown the different self MHC and self peptide combinations, तो ये दिखाया जाएगा कि ये तुम्हारी बहन है, ये तुम्हारा भाई है, अब देखो, तो ये immature सेल को दिखाया जा रहा है। Still if some are not listening and strongly reacting कि नहीं चिपक ही गए, तो उनको मार देंगे, so you are going to kill all those which very strongly react with your own peptides, with your own antigens, and those which do not, जो समझ गए, समझदार थे, okay, they are not reacting, they are not sticking to your own antigens, you will allow them to live. So basically you are disciplining. So positive selection, I told you, double positive cells will audition, of which only 10% will survive. So they will differentiate either into CD4 positive or CD8 positive depending upon whether they are recognizing MHC class 2 or MHC class 1. नेगेटिव सिलेक्शन होगा मेडुला में, जहाँ पे अब जो एक्चुअल डिसिप्लिनिंग शुरू होगा, तो जो सिंगल पॉजिटिव सेल अब CD4 CD8 आ गए हैं उनको दिखाया जाएगा सेल्फ पेप्टाइड। अब कैसे दिखाओगे सेल्फ पेप्टाइड? इतने सारे सेल्फ पेप्टाइड है, इंसुलिन है, गैस्ट्रिक एंटीजन है, कोई इंटेस्टाइन का एंटीजन है, हाउ आर यू गोइंग टू शो देम ईच एंड एवरीथिंग, हाउ आर यू गोइंग टू शो? सो दिस इज अ वेरी इंपॉर्टेंट पार्ट कि सारे पेप्टाइड्स वहां पे पहुंचेंगे कैसे थाइमस में। सो दिस इज अ जीन कॉल्ड AIRE, autoimmune regulator. This gene stimulates expression of tissue restricted antigens in the thymus. Okay, tissue restricted means what? So different tissues of our body express, are behaving in a different manner. Liver cell is not the same as stomach cell, genome तो सब में same है, but expression कौन से genes unfold होंगे, कौन से proteins बनेंगे, is totally decided by the microenvironment over there. So similarly thymus का भी अपना microenvironment है. Thymus will not normally produce all the peptides of the body, but this particular gene, it stimulates the expression of the peripheral tissue restricted antigens in the thymus only for this purpose, only for the purposes of negative selection. तो negative selection में क्योंकि हमको दिखाना है कि भैया ये सारे हमारे family members हैं, you want to introduce all your family members to the new children that are getting formed, so that autoreactive clones will undergo apoptosis, will undergo clonal deletion. So anything which is sticking very strongly, like I told you, यहाँ पे ज़्यादा जोर से चिपकेगा तो उसको मार दिया जाएगा. So whenever we discuss, I'm saying cells, but these cells also represent clones. तो उस cell का जो अपना progeny है, वो पूरा clone ही मर जाएगा. So you're not going to kill only that particular cell. You're going to kill any cell that got produced from there. Okay. So you are very ruthless father or father-in-law or whatever, and you want to just kill the entire family of that particular child. Okay. Oh, I'm sorry, I'm not going to use that simile again. It's getting a little macabre. So basically you just understand that clonal deletion refers to, so negative selection happens by clonal deletion, that all the autoreactive clones will undergo deletion. Some, okay, so अब देखो यहाँ पे जो बहुत जोर से चिपक रहे थे, they are killed by apoptosis. Which had very low affinity, या जो नहीं चिपक रहे थे, they are, उनको अलाउ किया तो वो बाहर निकल जाएंगे, अब escape करके circulation में पहुंच जाएंगे, they will develop into the naive T cell that you know. some which are in between, जो बीच में है, कभी एक हाथ से पकड़ रहे हैं बस, okay, so they are intermediate affinity. उनको बॉडी क्या करता है कि द बॉडी एक जुगाड़ लगाता है, उसको लगता है कि अरे इसको तो यूज किया जा सकता है, इसको पेरिफेरल टॉलरेंस में यूज करेंगे, क्योंकि ये जानता तो है बट ठीक से नहीं जानता, तो ही नोज समवॉट दैट दिस इज माय सेल्फ एंटीजन, बट ही कैन आल्सो स्टिक टू इट. तो इंस्टेड व्हाई नॉट मेक हिम अ पुलिसमैन, कि ये जाके तो ये पुलिसमैन बन जाता है, तो इसको इसके अंदर फॉक्स पी3 नाम का जीन बढ़ा दिया जाता है. ओके, यू इंट्रोड्यूस फॉक्स पी3 इनटू इट एंड इट बिकम्स अ टी रेगुलेटरी सेल. So this is a Treg cell. This also recognizes, so this will only be for self antigens. This will not be for foreign antigens. These are for various antigens, right? Anything which does not bind to this will become a naive T cell. But these are like intermediate affinity ones. So these are T regulatory cells. So a fraction of the CD4 positive cells differentiate into T regulatory cells. So again the same thing. Cortex में क्या होता है? Positive या negative? Positive. So positive selection happens in the cortex, in which your double positive T cells will be filtered on the basis of MHC recognition. And then in the medulla happens negative selection, where your single positive T cells, now either CD4 or CD8, will be filtered on the basis of affinity to self peptides. The self peptide, जैसे ये medullary thymic epithelial cell है, this is cortical thymic epithelial cell, this is medullary thymic epithelial cell. तो इसके अंदर because of AIRE, you can produce all sorts of peptides and you can showcase all sorts of peptides कि ये मेरा family member number 1 है, family member number 10,000 है, तो ये मिलेगा उससे, और ये अगर नहीं चिपक रहा है तो selected है, तो it becomes a conventional naive T cell. बहुत जोर से चिपक रहा है then rejected है, it will be killed. Intermediate affinity है तो इसको चलो policeman बना दो, regulatory T cell. So this is AIRE का medical. So whenever I make this किसका staff है ये, forgot, one Greek god of medicine, Asclepius या किसी का. So this means I'm talking about medical things, okay, things of medical significance. So importance AIRE, it is important for central T tolerance. If you are asked to write a short note, AIRE, autoimmune regulator, it is critical for central T tolerance. It enables the expression of tissue restricted antigens in the thymic medullary cells, which is used for negative selection of the T cells, immature T cells. And what happens in negative selection, that any self reactive clone will be deleted. अब अगर इसमें ही mutation है, okay, what will happen? You cannot show them all the tissue restricted antigens, and so तुमने सारे फैमिली मेंबर्स को इंट्रोड्यूस कराया तो नहीं है, तो अब बड़े होके उसको क्या पता कि किससे मिलना है, नहीं मिलना है, किससे शादी करनी है. He will meet अपने ही cousins मिलेगा. So mutation deletion of this particular gene can lead to failure of negative selection, failure of central T cell tolerance, and then that T cell will go out, stimulate the B cell to produce autoantibodies, and there will be severe inflammatory destruction of multiple organs, the condition called APECED, EPICED, autoimmune polyendocrinopathy, candidiasis, ectodermal dystrophy. Okay. Coming to central B cell tolerance. So central B cell tolerance may be deletion, like T cell mein you learned that. See, the difference between central T and B are the way in which antigen is presented. In T cell, how is antigen presented? By the antigen presenting cell, right? For immature B cells, you don't need that, that gift wrapping. तामझाम नहीं चाहिए. B cell को इतना presentation present, वो ऐसे ही फेंक के भी दे दो पेन तो चलेगा. T cell को है कि नहीं, पेन को पहले हार्ट शेप बॉक्स में डालो, उसके ऊपर रिबन लगा के फिर दो. बट B cell को नहीं, ऐसे ही फेंक के भी दे दोगे तो कैच करके यूज कर लेगा. So the only difference is how the antigen is exposed. Okay, and then there is one important addition, so one important new phenomena, that is receptor editing. In fact, to an extent, it also happens in immature T cells. Okay, so just learn of the two things: clonal deletion and receptor editing. What is receptor editing? Immature B cells which strongly recognize self antigens, in those the recombination activating genes will get reactivated, and they will cause receptor gene rearrangement to express new B cell receptor. So what is happening here? That an immature child, immature B cells, which was recognizing a particular self antigen, is now, instead of killing them, you are trying to discipline them, you are trying to change their outlook. कि नहीं नहीं देखो, तुम इसको पसंद कर लो, इसको छोड़ दो, तुम एक काम करो, मैं तुमको ये खिलौना देता हूँ. ओके, करते हैं ना बच्चों के साथ. कि नहीं नहीं अच्छा वो खिलौना टूट गया, अच्छा ये ले लो, ये वाला लो. So you are again doing the receptor gene rearrangement to express new B cell receptor. It is postulated that nearly 25 to 50% of all B cells in the body may have undergone receptor editing. But अगर उससे नहीं मानता है तो you have to kill them. फिर तो और कोई इलाज नहीं है. So if receptor editing does not occur, then apoptosis. So you see here, so this is the original receptor. Okay, variable VDGA को यूज करके एक कॉम्बिनेशन बनाया था. तो एक रेड कलर का रिसेप्टर, डेंजर, रेड इज डेंजर, राइट. तो रेड कलर का कैसे हम अलाउ कर सकते हैं, नहीं कर सकते हैं. तो उसको समझाया कि नहीं नहीं रुक जा. तो डेवलपमेंट वाज स्टॉप देयर एंड अगेन रैग 1 रैग 2 वाज एक्टिवेटेड. अगेन बोला कि नहीं फिर से कंबाइन करो. तो अब इसने येलो वेरिएबल सेगमेंट के बदले ब्लू वाला ले लिया, दूसरा ये वाला फ्रेगमेंट उठाया, राइट. और बाकी डी और जे सेम रखा. तो अब एक नया नया ग्रीन, ओ ये पास हो गया, चलो. एडिटेड रिसेप्टर नाउ रिकॉग्नाइजेस अ डिफरेंट एंटीजन एंड इट कैन बी रीचेक्ड फॉर स्पेसिफिसिटी. तो ये करके ये पास हो जाएगा. बट अगर नहीं मानता है या एक बार ट्राई किया फिर से रेड बनाया, देन यू कैन किल इट. सो this is just a brief short note on clonal deletion. So what is clonal deletion? It is death by death by apoptosis, not killing in the sense. It is self-programmed cell death. It is apoptosis. Okay, it is killing of a particular clone. So particular cell and its entire progeny that recognizes a self antigen. So functionally immature cells of a clone encountering the self antigens undergo programmed cell death. तो कहाँ कहाँ पे क्लोनल डिलीशन होता है? लाइक वी सॉ थाइमस में होता है फॉर नेगेटिव सिलेक्शन, बोन मैरो में होता है फॉर सोल्यूबल और सेल एसोसिएटेड एंटीजन व्हाटएवर, पेरिफेरी में भी होता है. तो जो इनिशियल टेबल हमने देखा था सेंट्रल और पेरिफेरल, क्लोनल डिलीशन कैन आल्सो हैपन इन द पेरिफेरी. So that is also a mechanism of peripheral tolerance. I'm just giving you points for writing a short note. Okay. पेरिफेरी में अब हो गया कि भैया स्कूल में तो ट्राई किया समझाने का, घर में स्कूल में बचपन में. They have now grown up. Okay, they are adolescents. They are started dating. So these are grown ups. Mature T cells, mature B cells का भी हम बात करेंगे दोनों का. So, but they have escaped the central tolerance. So now but they are still self-reactive. So something needs to be done about them. Okay, ऐसे वैलेंटाइन डे कैसे मनाने दे सकते हैं, हम तो शिवसेना है. तो we have to do some तोड़ फोड़. The normal T cell response is that your T cell reacts with the antigen presenting cell using your T cell receptor peptide MHC signal 1, CD28B7 signal 2. They will in signal 1 and 2 will activate interleukin 2 gene, interleukin 2 receptor gene that will through autocrine signaling cause proliferation of T cells. तो ये सब नॉर्मल हो गया. अब मीटिंग को तो नहीं रोक सकते, मीटिंग तो होगा, बट यू डोंट वांट कि मीटिंग के आगे भी बढ़े. लाइक दे शुड नॉट डू एनीथिंग बियॉन्ड दैट. ठीक है, मिल लिया कजिन वजिन से, इट्स ऑल राइट, बट अब बात को यहीं खत्म करो, आगे मत बढ़ाओ बात को. सो एनर्जी, okay, these are three terms: energy, deletion you already learnt. Okay, it is not different from that. And suppression, so this is also new. एनर्जी में क्या होता है कि सिग्नल 1 तो जाता है बट सिग्नल 2 नहीं मिल रहा है, रेड सिग्नल स्टॉप. So because of that it will be functionally, even though it meets, but it is functionally unresponsive. So unresponsiveness है. See here you are actually making the meeting. Okay, there in central tolerance you were just showing the picture कि देखो ये पिक्चर दिखा दिया वहां पे, क्योंकि एक्चुअल एंटीजन तो स्टमक का यहाँ पे है, स्टमक में है, इंटेस्टाइन का यहाँ पे है. वहां तो हमने जस्ट प्रोड्यूस किया था उसका कॉपी और उसको दिखा दिया था. सो दैट वाज लाइक यू आर शोइंग अ पिक्चर दैट दिस इज योर cousin. Okay, you don't need to meet them when you grow up. Here they are actually meeting their cousins and now you have to do something about it. So you're making them functionally unresponsive. Energy deletion is that there is no second signal, but as soon as they engage, so basically you know that Pandu को श्राप मिला था कि कुछ भी करेगा तो he will die, so he cannot. So simply it is like that कि मुनि ने श्राप दिया है कि if you do this with your own family member you will die. So it is activation induced cell death. Okay, deletion. And then there is suppression. So I told you there was a policeman, T regulatory cell. So that policeman is going and it is stopping this meeting. It is going and disrupting. So blocking in activation. So coming one by one to them. Anergy, that lymphocytes which recognize self-antigens are rendered functionally unresponsive. How? Because signal 1, T cell receptor with peptide MHC, signal 2, CD28 with B7. So signal 1 is present, but signal 2 is absent. It leads to Anergy. Signal 1, signal 2, repeat है सारा, बार बार नहीं बोलूँगा, बोर हो जाओगे. तो I'm sorry. So what I'm saying, so before अब Anergy समझाने के पहले एक नया player introduce करते हैं. So CTLA4 is a new player, okay? CTLA4, I forgot the full form. CTLA4 is the structural analog of CD28. तो CD28 की तरह ही दिखता है. Okay, this is CD28. उसके साथ समझ लो कि यहाँ पे एक और है CTLA4. वो भी इसको ऑक्यूपाई कर सकता है B7 को. Okay, and that has 20 times more affinity for B7 than CD28 has. So it binds to B7 with a higher affinity but causes inhibition. तो सेकेंड स्पेशलिटी उसका ये, पहला स्पेशलिटी है कि ज्यादा एफिनिटी से बाइंड करता है. सेकेंड स्पेशलिटी है कि वो इंस्टेड ऑफ सेंडिंग सिग्नल 2 इट विल सेंड एन इनहिबिटरी सिग्नल. So CTLA4, let's say here, this is the diagram. So you can see this is a T cell receptor and peptide MHC ने signal 1 दिया. CD28 and B7, B71, B72 को we also call CD80 and CD86. So you should not get confused between the two. These are the co-stimulatory molecules, right? This is the stimulation part, this is the co-stimulation part. So CD28 से signal 2 मिला, both cause T cell activation. Now, if there was another receptor called CTLA4 present here, which preferentially binds to the CD8086, and instead of sending a signal 2, it sends an inhibitory signal. What will happen? T cell inactivation. This is also known as T cell anergy. तो ये कब होता है? So clonal. So whenever the CD8086 are in abundance, B7 बहुत सारा है, तब तो CD28 के साथ bind करेगा, तब activation हो जाएगा. Okay. But if CD8086 is very less, B7 is very less, then तुम्हारे पास दो चीजें हैं. ये बहुत हाई एफिनिटी रिसेप्टर है, ये लो एफिनिटी. अगर थोड़ा सा ही B7 मॉलिक्यूल्स है, CD8086 है, किससे बाइंड करेंगे? So they will preferentially bind to CTLA4 because it has a higher affinity. So at low levels of expression of co-stimulatory molecules, the CTLA4 engages the antigen presenting cell and thereby leads to T cell inactivation. What is the importance of it? That I told you in the previous recap that during the innate immune response of the antigen presenting cell, two things happen. That antigen presenting cell, no, this is an antigen presenting cell. What does it do? What does the innate immune response do? It allows the antigen presenting cell to actually ingest the antigen, process it, and bring it out. Also, it increases the expression of co-stimulatory molecules. So both the things are important. Antigen presentation is also important. Co-stimulatory molecules expression is also important. So if your innate immune response, so CTLA4 is preferentially engaged when levels of B7 are low. Example, resting APCs. So resting state में antigen presenting cell है, उसका B7 बहुत low है. So that is the case when they are presenting self antigens. In contrast, when microbial बाहर से कुछ microbe आया है, then innate system को भी पहले activate करेगा. जो SARS corona virus है, पहले innate को भी करेगा. वो B7 वगैरह को बढ़ाएगा. So these B7 on the APCs increase and now they are able to engage the CD28. Now they will be active. So यहाँ पे T cell activation होगा, but जब self antigens को कर रहा होगा तब तो innate हुआ नहीं है. So there is no innate response. So there is T cell inactivation. Again, the medical significance being that some gene mutations of CTLA4, some polymorphisms are associated with impaired peripheral tolerance. So CTLA4 अगर आपका काम नहीं कर रहा है, then even the self antigens, even your self antigens, CTLA4 अगर काम नहीं कर रहा है, तो अगर resting state में भी है APC, it will be able to engage the T cell through CD28. It will be able to activate the T cell. So failure of peripheral tolerance causing autoimmune endocrine diseases. Okay. Again, if you want to block, just let me check whether the video is happening or not. I'm sorry. रिकॉर्ड हो रहा है कि नहीं भाई? स्क्रीन शेयर हो रहा है कि नहीं? ठीक है, हो रहा है. Fine. So yeah, I was saying another medical significance of CTLA4. So this is very important. I want all of you to focus yourself on this particular slide. The slide is the same. Okay. What I'm saying is that some cancer antigens, some tumors, and some viruses, what do? To avoid the immune system, they will wear mask. कोरोना जैसा मास्क नहीं, but मिशन इम्पॉसिबल टाइप मास्क. मिशन इम्पॉसिबल में टॉम क्रूज जैसा पहनता है, तो ही चेंजेस हिज लुक, राइट? दूसरे की तरह दिखने लगता है, विलन की तरह दिखने लगता है. सो हियर ऑल्सो योर ट्यूमर्स एंड वायरसेस, दे वेयर द मास्क ऑफ गुड गाइज. हमारे सेल्फ एंटीजन का मास्क पहन लेते हैं, बोलते हैं कि भाई मैं सेल्फ हूँ, मुझे मत मारो. So they use inhibitory, so they use the same pathway CTLA4 to evade the immune attack by inducing peripheral energy. So energy हो जाता है, नहीं मार पाता है. But if you block that kind of, so like I told you, if you want to increase power immune का बढ़ाना है, 5 पे करना है, तो टॉलरेंस को कम करना पड़ेगा. टॉलरेंस को कम कैसे करोगे? So this CTLA4 is mediating peripheral tolerance. You block CTLA4 action by using an antibody. So antibody against CTLA4 will engage CTLA4. Now CD28 is the only thing available for binding to B7. So now T cell will get activated. So in cases of cancers, this has fetched the Nobel Prize 2 years back, Nobel Prize in Medicine, to Dr. George Allison of MD Anderson Cancer Center, Texas, and another scientist from Japan. So both of them, they won this Nobel Prize for finding out, discovering this therapy, that using by blocking CTLA4 or by blocking PD1, this is another such receptor. It is called PD1 checkpoint. Using PD1 checkpoint inhibitors, you can down-regulate tolerance and up-regulate the immunity to attack your cancer cells. So this is immunotherapy. Okay. Another application will be in case of graft rejection, to prevent transplant rejection. तो यहाँ उल्टा होगा. Transplant rejection में you want that tolerance बढ़ जाए. So here what you are going to do, you are going to occupy, you are going to see, normally ये graft का antigen को process करके present किया and T cell got activated, it killed the graft rejected. But here what you are trying to engage the B7. B7 को आपने CTLA4 immunoglobulin, this is not the same as anti-CTLA4, ये anti-CTLA4 था. यहाँ पे आएगी CTLA4 looking like CTLA4 का जो ये top part है, इसको लेके आप IgG के या IgM के constant fragment में attach कर दो. That is a chimeric antibody. So this chimeric antibody will go and stick to B7. So B7 will not be available to bind to CD28. Signal 2 will not be delivered. So basically, just remember that Anergy refers to functional unresponsiveness of the T lymphocyte because the signal 2 is not getting delivered. Either, why is it not getting delivered? Either because your costimulatory molecule are attaching to an inhibitory receptor like CTLA4, or because they are not available, they are simply attaching somewhere else. So non-engagement of the CD28. Coming to the second mechanism, policeman. So first वो हमने बीच वाला अभी skip किया है. We came to the third one, policeman. Okay, so this is again very important to understand what is a T regulatory cell. So I told you T regulatory cell कहाँ पे बनते हैं? Thymus में बनते हैं at the stage of negative selection. Negative selection में जो intermediate affinity के होते हैं, उसको हम बॉडी सोचता है कि इसको पुलिसमैन बना देंगे, इसको पुलिस का कॉस्ट्यूम दो, इसको बोलो कि ठीक है तू पहचानता तो है सेल्फ एंटीजन को बट थोड़ा पहचानता है, तो जस्ट यू गो एंड यू प्रिवेंट अटैक. ओके. So T cells, called regulatory T cells, are important for peripheral tolerance. They are formed in the thymus, but they work in the periphery. So they are called peripheral tolerance. B में भी होते हैं regulatory, but more important are the T regulatory cells. So they are CD4 positive cells. Okay. So initial days में they were also called T suppressor or TS cells, and they were thought to be CD8 cells, but now we know they are CD4 cells. What is the specialty? CD4 cells, they express high levels of interleukin 2 receptor alpha chain. तो interleukin 2 का जो receptor था, जो autocrine signaling से activate करता था, that receptor has two chains, alpha and beta. So here alpha chain is overexpressed in these cells, and also like I told you, transcription factor FOXP3 भी overexpressed होता है. So what you must learn is that suppression is antigen specific. मतलब ये पुलिसमैन जो है ये एक पर्टिकुलर एंटीजन को ही रिकॉग्नाइज करता है, उसी से नहीं मिलने देगा. So a possessive father-in-law, a possessive mother-in-law is going to protect his or her daughter or son, daughter from a rogue. कि इससे नहीं मिलना है, ये तो बुरा लड़का है, या ये अपने whatever, जो भी तुमको सोचना सोच लो। तो इट इज नॉट गोइंग टू प्रोटेक्ट दूसरे पूरे मोहल्ले के बेटे बेटियों का ठेका नहीं लेके रखेगा। सो दे so this suppression is antigen specific. So T regulatory cell against a particular antigen will protect that particular antigen alone. Okay. And of course the importance is that they inhibit the development of autoimmune and chronic inflammatory diseases. अगर वो नहीं होंगे तो ये सब हो सकता है। So like I told you, बनते हैं थाइमस में, जो नाइफ बन रहे होते हैं जहां से, वहीं से कुछ को टी रैग बना दिया जाता है, उनमें FOXP3 ज्यादा होता है। Although even in the periphery, the naive T cell, see this is the naive T cell getting activated and getting activated and क्या बोलते हैं उसे, proliferation and differentiation into T helper 1, T helper 2 और T helper 17। T helper 1 जो कि इंटरफेरॉन गामा सिक्रीट करता है और मैक्रोफेज को एक्टिवेट करता है टू किल। T helper 2 जो इंटरलूकिन 4-5 सिक्रीट करता है, जो IgE प्रोडक्शन कराता है from the plasma cells, and it also activates eosinophils to kill parasites। TH17 which secretes interleukin 17, 21, 22, attracts neutrophils, macrophages, induces inflammation to kill bacteria। So this is the normal T cell response। Occasionally even the naive T cell can form a T regulatory cell, so but majority will be formed from the thymus itself। So this is thymus or the central T regulatory cell, this is peripheral T regulatory cell। Okay. This is a flow cytometry, not very important, but जो आपका CD4 पॉजिटिव टी सेल्स है, उनको अगर आप फ्लो साइटोमेट्री करोगे तो उसमें जिनका CD25 ज्यादा है और जिसका FOXP3 ज्यादा है, okay, this is the first quadrant having high CD25 and high FOXP3, and they are of course all are CD4 positive। So these are your T regulatory cells। These are CD4 positive but low CD25, low FOXP3, so these are your normal T helper cells, the conventional T cells। These are the regulatory T cells। सो हाउ मैकेनिज्म, हाउ डू दे, अब ये करते कैसे काम, मतलब पुलिसमैन बना के भेज दिया ना, अब पेरिफेरी में क्या होगा कि मीटिंग कहीं चल रहा है, कैफे में मिले हैं लड़का लड़की, तो अब ये क्या करेगा जाके, तो वो लड़के को बात नहीं करने देगा लड़की से, फॉर एग्जाम्पल अपनी बेटी से बात नहीं करने देगा, तो ही विल गो एंड स्टार्ट टॉकिंग टू द गर्ल। तो हाउ, so he will express, so they express CTLA4। Okay, this is your T regulatory cell, it has CD25, it has FOXP3, also it has high CTLA4। CTLA4 can bind to the B7, and of course B7 फिर यहाँ पे इसने engage कर लिया, so that B7 is less available to bind to your T helper cell, so there it reduces the ability to activate T cells via CD28। Okay, that mechanism is clear। Second mechanism is that it can secrete inhibitory substances like interleukin 10, TGF beta, so TGF beta वगैरह, they will go and suppress the activation of the T lymphocyte। तो ये भी कर सकता है। So this is your T regulatory cell, this is your dendritic cell presenting self antigen, this is your T effector cell। Okay, conventional T cell जो आपका है, मतलब यही आ गया है basically। This is your auto, so okay, बहुत बोल रहा हूँ, थोड़ा शांत हो जाने दो मुझे। So what I'm saying is that this is a dendritic cell which is presenting a self antigen, and this is an autoreactive T lymphocyte। Okay, autoreactive T lymphocyte which is going to recognize and may attack your antigen, may get recognized, may get activated by this antigen। So now the T regulatory cell, what it is going to do? So this is a T regulatory cell, you can see expressing high CD25, which is the interleukin 2 receptor, and secreting interleukin 10, TGF beta। So one thing is that T effector cell will receive signal 1, signal 2, and secrete what? Interleukin 2। But now because interleukin 2 receptor is more on this T regulatory cell, the autocrine signaling will be impaired because some IL-2 will go here। Okay, so one mechanism is sharing of the autocrine signaling, so that is why interfering with the autocrine signaling। Second is interfering with the co-stimulatory molecule। So like I said, Treg has CTLA4, and this CTLA4 is going to engage your co-stimulatory molecules, prevent them from interacting with CD28 here। So mechanism 1, interference with autocrine signaling। Mechanism 2, not allowing signal 2 to happen। Actually पहले उसको बोलो कि signal 2 होने नहीं देगा by engaging CD86। If signal 2 happens, then it will interfere with the autocrine signaling, उससे भी नहीं हुआ, it will secrete TGF beta, interleukin 10 to prevent कि this should not go into mitosis, this should not get activated. उससे भी नहीं हुआ तो it can also kill, so it can secrete perforin granzymes to cause death. Okay, so competing with the T effector cell for interaction with dendritic cell, that is one mechanism. The regulatory cell, you can see here, out competing the T effector cell. Modulation of APC function, so they can just directly affect the function, by secreting interleukin 10, by secreting TGF beta, so they can inhibit the activation, killing and inactivation. So finally, it can just secrete granzymes and perforins and kill, so that it can do. So medical significance क्या है इसका? Again, Treg cells are important. So short note में ये लिखना है कि they are important for peripheral tolerance. Short note में what you will write about regulatory T cells? They are CD4 positive cells. They are formed in the thymus. They have intermediate affinity for self antigens. They overexpress CD25. They overexpress FOXP3. In the peripheral lymphoid organs, what do? They inhibit the activation of T cells. How they inhibit? By preventing signal 2, through their CTLA4, by preventing autocrine signaling. How? Through their interleukin 2 receptor. And then what is the third mechanism I said? By preventing the activation of the T lymphocyte by interfering with them through IL-10, TGF beta. Fourth is directly killing them. So all that, so important peripheral tolerance. If the FOXP3 is mutated, then a condition called IPEX, immune dysregulation, polyendocrinopathy, entropathy, X-linked, this results. So basically FOXP3 के mutation होने से क्या होगा? T regulatory cell का function affect हो जाएगा, and then it will lead to some systemic autoimmune disease. CD25 gene polymorphisms have been found in certain multiple sclerosis. So multiple sclerosis is a condition where antibodies are produced against the myelin of the brain. So, but I'm saying that some CD25 gene polymorphisms have been found associated. So a possible role of T regulatory cells is also there, can also be there. Okay. Fetus acceptance. So this is a very interesting aspect of Treg, that Tregs prevent immune reactions against the fetal antigen. So basically, for every mother, the fetus is a foreigner. Why? Because the HLA complement of the fetus and mother can never match. The fetus has half HLA genes of mother and half from the father. Okay, siblings can be histocompatible, but parents can never be histocompatible with their child. You're understanding this. Still, the mother's T cells do not mount an immune response against the fetus. How does that happen? So that happens because the T regulatory cells are thought to prevent this from happening. Okay. Other autoimmune diseases like SLE, rheumatoid arthritis are also associated with Treg cells. Treg cells may also suppress immune response to tumor antigens. So this is again another applied aspect, that some T regulatory cells can actually start acting as policemen for the cancer cells. तो उल्टा ही काम कर रहा है. हमने बोला है कि हमारे एंटीजन को बचाना है, जाके कैंसर एंटीजन को बचा रहा है. हिम्मत तो देखो. तो एलिमिनेशन, तो उनका क्या करना है? उनको हटाओ, फिर वो पुलिस वाला तो रोग है ना. तो लाइक यू डोंट नीड सच पुलिसमैन, corrupt police. So elimination of such Treg cells can actually facilitate anti-tumor immunity. Conversely, you might want to increase the Treg cells when you want to suppress. So when you want to give an organ transplant, or when the patient is suffering from autoimmune diseases, allergies, तो तब Treg बढ़ा दोगे आप, tolerance बढ़ जाएगा. Okay, so now coming to the clonal deletion part, the third mechanism tha. So you learned about peripheral Anergy, you learned about T regulatory cells, and now we are learning about deletion, also known as activation induced cell death. So what happens is that if the autoreactive T cell T cell receptor is engaged by self antigen, that nahi hi mana, okay, mil hi liya, we asked them not to meet, still they met, and they also went ahead, So if they went ahead, what will happen? It will die automatically. So how he will die? Because he is not supposed to do that. So how he will die? They may express a pro-apoptotic member of the BCL family called BIM. So अपने surface पे एक BIM नाम का protein. So there are some apoptotic proteins like BAD, BAX, BIM. So BIM express करता है, उससे मर जाता है. Secondly, FAS and FAS ligand are co-expressed, leading to elimination. So FAS, you will learn about FAS and FAS ligand in your second year as well. So basically, there are some receptors, transmembrane proteins on the cells known as death receptors. So death receptors, because if they are engaged by their ligands, they activate apoptotic pathways. So FAS is one such receptor. So if the FAS ligand comes and sits on that FAS receptor, apoptotic pathway will be activated. Now, if an autoreactive T cell ultimately engages the self antigen and tries to do anything, the FAS ligand also starts getting co-expressed. So we'll see in the diagram picture. So this is your dendritic cell presenting a self antigen, presenting an antigen in general. Okay, CD4 T cell coming and recognizing. You can see the peptide MHC, meaning T cell receptor combining with the peptide MHC. CD4 going and recognizing your MHC alone, जैसा होता है. And it will give signal 1, signal 2, interleukin will get activated, autocrine signaling activate होगा. ये सब normal conditions में होगा. Now coming to a condition where this peptide was not foreign, it was self. तो अब क्या होगा? FAS will start, FAS and FAS ligand both will start getting overexpressed. So FAS ligand भी बहुत सारा आएगा, FAS भी आएगा. Ultimately FAS ligand will come into contact with FAS and the cells will undergo apoptosis. So self-reactive B cells may be deleted by FAS ligand, FAS and FAS ligand. In fact, the FAS ligand on T cells can also engage the FAS on B cells. That also can happen. Just pause the recording for a while. Yeah, to come back. So we said that there is, if the cell eventually undergoes, if the T cell eventually does engage with its self antigen, FAS and FAS ligand get co-expressed, and as they interact, it leads to activation-induced cell death. FAS on B cells can also get activated by FAS ligand on T cells. So that also can help. So the importance of it is indicated by the fact that mutation in FAS gene can cause a condition called autoimmune lymphoproliferative syndrome. So basically, FAS is important for peripheral tolerance. Tregs are important for peripheral tolerance. And what else did you learn? The third one, CTLA4 is important for peripheral tolerance. So if you can interfere with CTLA4 or with polymorphisms in CTLA4, if there are T regulatory cells like CD25 polymorphisms, or if there are mutations in FAS, all lead to peripheral breakdown in peripheral tolerance and some or the other autoimmune conditions. Okay. Peripheral B cell tolerance also follows more or less the same things. So you can see the normal response, normal B lymphocyte binds foreign antigens, gets activated into memory and effector, वो सब होगा. But if the B cell binds self antigen, what happens? Either it gets killed, like we saw activation induced cell death, or it undergoes anergy, or immune regulatory cells like Tregs होता है, यहाँ पे Bregs भी होता है, या Treg इसको भी करेगा. So the same mechanism, apoptosis, anergy, and regulation. So peripheral tolerance is deletion, anergy, or regulation. So you remember the T dependent antigens and T independent antigens? You remember the two things, right? Oh, I'm sorry. So here what I meant to say is that the peripheral mechanisms of B cell tolerance are also helped by peripheral T cell tolerance. How? Because T dependent antigens, right? Many autoreactive B cells, even after binding to the self antigen, peptides, especially जितने भी peptides को bind करेंगे, they need the T helper to bind. Okay, so T helper, I didn't bring that picture, but you remember that picture. Okay, there is the, okay, I will show you that picture. Yeah. Where's my cursor? I'm sorry. So you can see here the B lymphocyte. Okay, B lymphocyte has bound its own antigen using its surface immunoglobulin. It has not been shown. यहाँ पे समझ लो कि एक surface immunoglobulin है, peptide है. So B cell has become activated, but it will not start proliferating until this happens. What? So the activated T helper cell. So B cell will first ingest the particular antigen, present it with an MHC2, so that the activated T helper cell will recognize that MHC peptide complex. Come here, and then the activated helper cell expresses something known as CD40 ligand. Okay, and B cell has the CD40. So this provides signal 2. So this provides signal 1. Rather, signal 1 was provided by the surface immunoglobulin and protein interaction. So that had happened before. Okay, I didn't mention that. I didn't show that. So this particular gave signal 1. This is the thing. This is the thing. I'm sorry. So you have your B lymphocyte. This immunoglobulin and peptide interaction delivered the signal 1. The signal 2 was delivered when the activated T helper cell came face to face with the B cell, and the CD40 on the B cell was engaged by CD40 ligand. So this was signal 2. So now we'll come to this particular thing. So we saw, so I was discussing that apoptosis, energy, and regulation, these are the three mechanisms of peripheral B cell tolerance. So for T-dependent antigens, autoreactive B cells, even after binding their self-antigen, require the help of Th to provide signal 2, CD40 ligand expressed on this, right? And also, other cytokines, जो भी cytokines है, interleukin 4, interleukin 5, ये सब भी तो T cell से ही आता है ना. So that too, so without such help, it undergoes anergy or apoptosis. Okay, I'm very tired. It's a long lecture, but the last slide, just focus on this last slide. So immune privilege. So we discussed mechanisms of central T and B cell tolerance, peripheral T and B cell tolerance. Now I'm coming to a concept of immune privilege. Okay. Immune privilege means that some antigens are sequestered or hidden from the immune system because the tissues do not communicate with the blood and lymph. So these antigens, we are not actually training the immune system to become tolerant. We are not telling them that this is your sister or brother. Okay, you are just putting a big wall in front of them. You are shielding them behind a big wall. So एक बड़ा सा दीवार खड़ा कर दिया कि the immature children, these or the mature B lymphocytes, T lymphocytes, they cannot even see them. So if they cannot see them, the attraction का कुछ बात ही नहीं है. If you cannot see something, you don't know them, right? So basically, since you don't know them, it is called immunological ignorance. So these examples of immune privileged sites include the brain, the anterior chamber of the eye, the testis. Okay. So for example, the sperm of a male is unknown to the immune system. Immune system ने उसको देखा ही नहीं है. So the naive T lymphocyte or B lymphocyte will exist because tolerance नहीं हुआ. There is no deletion, no clonal deletion, no energy, nothing. Okay, no receptor editing. So they exist. The naive T cells, naive B cells exist, but they have not seen these antigens. So because the immune system is not normally exposed to this, so it is immunologic ignorance. Lymphoid cells stay in a state of immunologic ignorance. That is, they are neither activated nor energized. But if these antigens are released somehow due to trauma, due to infection, due to some factor, so then it can lead to prolonged tissue inflammation and injury. Example. So I'll give you an example. Post-traumatic orchitis. So if the testis gets injured and the testicular antigens are suddenly, now they come into contact with the circulation. Okay. So now it can lead to orchitis. Similarly, so this is very interesting, of sympathetic ophthalmia or sympathetic ophthalmitis, endophthalmitis. So what happens is that one eye gets injured. Okay, there is penetrating injury to one eye, and it gets infected and it gets all sort of things. You try to correct it, you try to repair it. Maybe you succeed, maybe you don't. Suddenly, after a few weeks, the other eye develops a rapid inflammation for no reason. So that is because when the first eye got injured, some antigens which were never exposed to the immune system got exposed. And now the immune system has cells to mount and has memory cells, has everything, and it mounts an immune response against the second eye, which is absolutely normal. One example, one mechanism of multiple sclerosis also could be through this, but that's not the only way multiple sclerosis develops. That is one thing. So coming to the summary of this particular lecture, tolerance is nothing but unresponsiveness, and self-tolerance means unresponsiveness to self-antigens. And this is a fundamental property. Breakdown of tolerance leads to autoimmune diseases. Tolerance is divided into central and peripheral mechanisms. Central is in the central lymphoid organs or generative lymphoid organs, where T cells and B cells are formed. So immature lymphocytes at this stage itself, if they recognize self-antigens, are killed by apoptosis. In B cell lineage, there is another mechanism known as receptor editing. That is, some self-reactive immature lymphocytes switch to new antigen receptors that are not self-reactive. So they are given new toys to play with. Okay. Peripheral is that when mature lymphocytes which have escaped central T tolerance, okay, mature lymphocytes, and they recognize self antigens, they become functional. So there are three mechanisms: either they become functionally inactive, Anergy, or they are suppressed by T regulatory cells, or they die by apoptosis. So in the next lecture, we'll now focus on what happens if this tolerance is breached and it leads to an autoimmune condition. Okay, thank you so much.